Okay, welcome to part 2 of 1.1 Global Warming and Climate Change lecture video. In this video, we are focusing on the last two boxes in here on this table. First one is ocean acidification is caused by the ocean absorbing higher levels of carbon dioxide from the atmosphere. What you need to be able to do is to describe and write equations to show how carbon dioxide lowers the pH of the oceans. What you also need to be able to do is calculate the pH of solutions given the concentration of H plus or OH minus and vice versa. And the last one is the skeletons and the shells of many marine organisms are made of calcium carbonate and are vulnerable to dissolution at low pH. You need to be able to write equations for carbonates reacting in acidic conditions. So a few equations and formula involved. So let's look through that. So firstly, ocean acidification bit. It's a third last slide, which is this one. All right. So carbon dioxide is soluble in sea and reacts from to form carbonic acid. Let's just write that equation. So carbon dioxide. So first one there. CO2 gas, H2O liquid. So that's the dissolution that's happening. So H2CO3 being carbonic acid, and that just got generated from carbon dioxide being dissolved into water. And secondly, carbonic acid is a weak acid and partially ionizes, forming hydronium ion and hydrogen carbonate ions. So you would start with H2CO3AQ. Now you could put water molecule here, which you don't have to, but what you must do is to use two-way arrow here to show that it's a two-way reaction, which happens for weak acids. If you take one hydrogen out of carbonic acid, you should get HCO3 with 1 minus dissolved plus H3O plus, which is hydronium ion. So that's the second equation there. And the third one there is about hydrogen carbonate ion further ionizes to form carbonate ions. So start with hydrogen carbonate ions. You can add water or without water. Actually, you are told to make hydronium ion, so you actually need water molecule there too. One of the ions that comes out is carbonates, so CO3 2 minus. So hydronium ion and a carbonate ion. They're the products that you would expect. And then next one is the next slide. All right. And this is where we also need to look at how pH can be calculated from concentration of hydronium/hydrogen ion or OH minuses. So let's look at the formula again. So to find the pH of something, you would always have to have negative log it's negative log 10, but when you press the button that says log on your calculator, that automatically becomes log 10 anyway. So negative log of concentration of hydrogen or hydronium ion, doesn't really make much difference. Hydronium ion would be a more realistic way of writing acidic, or concentration of hydrogen ion. If you want to reverse that, so if you are to calculate concentration of hydrogen or hydronium ion, you would have to put that into 10 to the power of negative pH, 10 to the power of negative pH. Then you would be able to get concentration of that. Now, for you to find concentration of OH minus, there are a few ways of doing it, but I guess the most common way would be to go through or rearrange this equation that you will see here. So H plus concentration and OH minus concentration. If you multiply them, you would always get 1.0 times by 10 to the power of negative 14. You would always get this number, 1.0 times by 10 to the power of negative 14, in the same solution. So, by rearranging this, you can then find out OH minus, for example, 1 times 10 to the power of negative 14 over H plus. Now, knowing this third equation here or formula here is extremely important, because you might be given a concentration of a base solution, but you still have to find a pH value. pH requires concentration of hydrogen or hydronium ion. So for you to find that, you might have to find hydrogen ion concentration, that's not very visible, first using this relationship here. Okay. There's also something else which is not really what you need to know, but there's what's called POH. It's a power of hydroxide ion, power of hydroxide ion, which can be found, if you guessed, negative log, same thing, but concentration of hydroxide ion. For you to find hydroxide ion's concentration, you can also do 10 to the power of negative POH. There's another one that you might find it useful, kind of similar to this one, this relationship here, is that if you add, if you add pH and POH of the same solution, you would always get 14. It's kind of similar to this. Yeah. From here, you can also sort of see that to find pH of a basic solution, firstly you find this. So negative log of known concentration of hydroxide, which gives you POH value. Say that was, I don't know, something like 1 or 2. And then if you take POH from 14, you should be able to find pH as well, couldn't you? So that will be like 14 take 2, therefore you get 12. And 12 is a basic pH value, so it's good to have that. That's about it for pH calculation. There's also summary page here. for what you need to know for this 1.1 part. So you can go through these questions or points that I've listed down there. Yeah, and then make sure you can do those pH calculations as well. Have plenty of practices. Okay, I think that's it. Right, I'll see you in the next video.